This video is about composition of functions. Okay, and in this case we are going to talk about a specific case. What I mean by that is we are going to have an x given rather than do everything in terms of x. So first of all, composition of functions, notation for it is f composition g, this little circle meaning composition of x, equals, by definition, this is actually f of g of x. So if we have two functions, for example, f of x equal to 2x plus 1 and g of x equal x plus 3. And since we want to do something more specific, let's say that x is given and it's equal to 5. What do we do? Well, this f composition of g of 5 in this case is equal to f of g of 5. So what are the steps here? Well, we need to find g of 5. Once we calculate that value, we say f of that value. So let's calculate. G of 5, so we are using this equation. G of 5 equals, well, instead of x we put 5 plus 3. So this tree looks funny. So now g of 5 equals to 5 plus 3, which is 8. So now we have this value that this whole thing here is equal to, right? Everything inside parentheses is equal to that. Now what we have here is just f of 8, because this whole thing is equal to 8. So this is just f of 8. So now we need to go into f of x function, which is right there, and then plug the 8 in. So f of 8 equals 2 times, instead of x right there, we put 8, and then we still have plus 1 from right here. So 2 times 8 is 16, plus 1 is 17. So composition f, composition g of 5, not of 5, oh yes, of 5, yes, is equal to 17. Okay. This is it for this kind of case, specific case, when we have x given. There is a slightly different way to do this case, but we'll explain this in the next video, in which we discuss the general case, which is the case in which we don't really have an x given, so we have to do the composition of functions in terms of x. If you like the video, please like it and below, and subscribe as well.